Subscribe Dr. Sadik Mathematics channel for getting more online videos.
Find the characteristic roots and the corresponding characteristic vectors of the matrix A that is equal to 6 minus 2 2 minus 2 3 1 2 minus 1 3. What are eigenvalues and eigenvectors? How to find eigenvalues and eigenvectors of the matrix. Today we discuss concept and problems on eigenvalues and eigenvectors. Let us see the definition of eigenvalues and eigenvectors. Let capital A be any square matrix of order m. This is important. A be any square matrix. Once again, A be any square matrix. Okay. There exists a non-zero vector x such that Ax that is equal to lambda x. This definition, this condition also very important. Ax that is equal to lambda x. Then this lambda is called eigenvalue of the matrix A. Once again, this lambda is called eigenvalue of the matrix A, and corresponding vector x is called eigenvector. Here lambda is called eigenvalue and x is called eigenvector. Let us see one example. Suppose he given A that is equal to 4 2 1 5 and x that is equal to 2 minus 1. Now what is left hand side here? Ax. So I want to take Ax here. Ax. Simply I multiply here, then we get a column matrix 6 minus 3. Taking common 3 here, then we get 2 minus 1. What is 2 minus 1? X. Now this is like lambda x. That means Ax that is equal to lambda x. Here 3 is called eigenvalue and 2 minus 1 is called eigenvector. 2 minus 1 is called eigenvector. Here he given A and x, friends. A and x. Suppose if he given only matrix A, then he says find eigenvalues and eigenvector. Then right, there is a working procedure, friends, to find eigenvalues and eigenvectors. Okay. Now here this eigenvalue is also called characteristic values or latent values or proper values or spectral values. Once again, these eigenvalues are also called characteristic values or latent values or proper values or spectral values. Okay. Similarly, eigenvector, friends, eigenvector, this one also called characteristic vector or latent vector or proper vector or spectral vector. Now let us see working rule. What, friends? Working rule to find eigenvalues and eigenvectors. Let us see the steps, friends. These are the steps. Okay. Let us see step 1. Let capital A be any square matrix of order n, A that is equal to matrix Aij n by n. Okay. Now I want to take the matrix of order 2, friends, of order 2. A that is equal to 4 2 1 5. Okay. Now what is step 2? Write the characteristic matrix. What, friends? Characteristic matrix. What is characteristic matrix? A minus lambda I. Okay. A minus lambda. Now write A minus lambda here. Simply A minus lambda that is equal to 4 minus lambda 2 1 5 minus lambda. And then write the characteristic equation determinant of A minus lambda I that is equal to 0. Now what is characteristic equation, friends? What is characteristic equation? Determinant of A minus lambda I that is equal to 0. Simple apply here. Determinant of A minus lambda I that is equal to 0. Now apply determinant to this matrix. That means we get here determinant of 4 minus lambda 2 1 5 minus lambda that is equal to 0. Now you expand this determinant, friends. You expand this determinant. We get an equation in terms of lambda. Okay, lambda. So this is lambda square minus 9 lambda plus 18 that is equal to 0. Now this equation is called characteristic equation. And then step 3 is solve the equation. We get n roots. okay, because order is n here, we get here n roots, but here order is 2, so we get here how many roots, friends? 2 roots. 2 roots. So lambda is equal to 3 comma 6. Here what he says here, lambda is equal lambda a, that means here lambda is equal 3 comma 6 is called eigenvalues. That means this 3 comma 6 are called eigenvalues. This 3 comma 6 are called eigenvalues. Okay, and then step 4 is at each lambda is equal lambda I. At each lambda is equal lambda I. That means here lambda is equal to 3 and lambda is equal to 6. That means case 1 is lambda is equal to 3 and case 2 is lambda is equal to 6. Okay, we solve the equation a minus lambda I into x, that is equal to 0. Okay, a minus lambda I into x, that is equal. That means here a minus 3i into x, that is equal to 0. Now we know this is homogeneous equation, friends. We know how to solve this homogeneous equation. Okay, there we get say x is capital X is x comma y. Okay, because here order is 2, so that I am taking here xy. Okay, for the lambda is equal to 3, we get here xy values as minus 2 comma 1. This matrix, column matrix minus 2 comma 1 is called eigenvector. Similarly, if I am taking here case 2 lambda is equal to 6, then we get xy value 1 comma 1. You write the matrix, column matrix form 1 comma 1. This one is called also eigenvector. Once again, friends, here he given a matrix, square matrix. What matrix, friends? Square matrix. The step 1 is you write characteristic matrix a minus lambda I. Okay, we get this. And step 2 is you write the characteristic equation. What is characteristic equation? A minus lambda I, determinant of a minus lambda I, that is equal to 0. We expand the determinant, we get a equation. Okay, we get a equation. This equation is very important, friends. This equation is very important. Okay, and then you solve this equation, we get the roots. These roots are called eigenvalues. Now we want to find here eigenvector. So for that, here a minus lambda into x, that is equal to 0. If I am taking lambda is equal to 3, if solve this homogeneous equation, we get xy values. So you write the xy values as column matrix minus 2 comma minus 2 1. Okay, and then lambda is equal to 6. So you solve this equation, we get another values 1 comma 1. If you write the column matrix, these two column matrices are called eigenvectors. Okay, this is about working rule, friends. Working rule. Now if you observe here, how many eigenvalues, friends, here? Eigenvalues, 2 eigenvalues. How many eigenvectors get, friends, here? 2 eigenvectors. Let us see one note, friends. Note. First one is corresponding to n distinct eigenvalues, we get n independent eigenvectors. Previously we have 2 eigenvalues, we get 2 eigenvectors, friends. If there is n distinct eigenvalues, we get n independent eigenvectors, friends. And then second note one is very important. When 2 or more eigenvalues are equal, it may or may not be possible to get eigenvectors corresponding to the repeated roots. For example, if I am taking here lambda is equal to 2 comma 2. That means 2 roots are repeated. For these two roots repeated, we sometimes may get one eigenvector. Okay, sometimes we may get 2 eigenvectors, friends. Once again, sometimes we may get one eigenvector, sometimes we may get 2 eigenvectors, friends. Okay, this is the meaning of this. Once again, when 2 or more eigenvalues are equal, it may or may not be possible to get eigenvectors corresponding to repeated roots. Okay, this is the meaning. Now we will see one problem on this repeated root, friends. Let us see. Important. Find the characteristic roots and the corresponding characteristic vectors of the matrix A, that is equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Okay, here we are finding eigenvalues and eigenvectors. See here, this is 2015, 12 and 11. Previous year question, very important problem, friends. Let us see the solution. Now you write a given matrix, friends. Given A that is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2 minus 1, 3, 2 minus 1, 3. Okay. Now, first step is write characteristic matrix. Okay. Characteristic matrix. What is characteristic matrix, friends? A minus lambda I. That is equal to matrix. Write down A, 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, minus lambda into unit matrix of order 3, friends. Unit matrix of order 3 here, because the matrix of A matrix order is 3. So, write unit matrix of order 3. So, 1 0 0 0 1 0 0 0 1. That is equal to 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3 minus, simply multiply with lambda, friends, here, lambda into 1 lambda. So, 0 0 0, lambda into 1 is lambda, 0 0 0, lambda into 1 is lambda. So, that is equal, we get here 6 minus lambda minus 2 2. So, that is equal to 6 minus lambda minus 2 2. Minus 2 2. Now, second row minus 2 3 minus lambda minus 1, minus 2 3 minus lambda minus 2 3 minus lambda minus 1. And third row is 2 minus 1 3 minus lambda, 2 minus 1 3 minus lambda, 3 minus lambda. Now, second step, friends, characteristic equation. Characteristic equation. What is characteristic equation? Determinant of A minus lambda I, that is equal to 0. That implies determinant of 6 minus lambda minus 2 2, okay, minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda, that is equal to 0. That is equal to 0. Now, expand the determinant, friends. Expand the determinant. We get here 6 minus lambda, okay, into, that means you delete first row and first column. Then we get here 3 minus lambda into 3 minus lambda. 3 minus lambda whole square minus, again minus into minus plus, 1 into 1 1, minus, we have minus 2 here. So, minus into minus plus 2. Now, this time you delete first row and second column, we get here minus 2 into 3 minus lambda minus 1 into 2 minus 2. So, minus into minus plus 2 plus 2 into, now this time you delete first row and third column, then we get minus 2 into minus 1, we get 2 minus 2 into 3 minus lambda, that is equal to 0. That is equal to 0. Now, 6 minus lambda, okay, expand, friends, here, then we get lambda square minus 2 into 3, 6 lambda 3 square plus 9 minus 1, 9 minus 1 means we get 8 plus 2 into, multiply with minus 2, that means we get here minus 2 into minus lambda, 2 plus 2 lambda, minus 2 into 3 minus 6 plus 4, we get here minus 4 plus 2 into, similarly multiply with minus 2 here, we get a 2 lambda minus 2 into 3 minus 6 plus 2, so we get minus 4 here, that is equal to 0. That is equal to 0. Now, multiply with 6, friends, here, we get here 6 lambda square minus 36 lambda, 6 8s are 48. Multiply with minus lambda, so we get a minus lambda cube, minus into minus plus 6 lambda square minus 8 lambda. See here friends, 2 lambda minus 4, 2 lambda minus 4. These two terms are same. So 2 plus 2, 4. So multiply with 4 friends. 4 2s are 8 lambda minus 4 4s are 16. That is equal to 0. That is equal. Now you write the degrees in descending order. So here we get a minus lambda cube, and then lambda square friends here. Lambda square. We get here 6 lambda square plus 6 lambda square. We get here plus 12 lambda square, plus 12 lambda square. Okay, 12 lambda square, and then lambda. So clearly here minus 8 lambda plus 8 lambda cancel here. We get minus 36 lambda. Minus 36 lambda. Now plus 48 minus 16. That means we get here plus 8 minus 6, 2, 4 minus 1, 3, 32. That is equal to 0. Simply multiply with minus here. Then you get lambda cube minus 12 lambda square. Lambda cube minus 12 lambda square. 12 lambda square plus 36 lambda minus 32 plus 36 lambda minus 32. That is equal to 0. That is equal to 0. Now apply Harner synthesis method to find the roots, friends. So what is lambda cube coefficient? 1. Okay, lambda square coefficient is minus 12. Lambda coefficient is 36, and the constant is minus 32. Take here lambda, that is equal to 2, friends. Lambda is equal to, apply 0 here. 1 plus 0 is 1. So 1 2s are 2. We get here minus 12 plus 2 minus 10. 2 into minus 10 minus 20. We get here 16. Okay, 2 16s are 32. So one of the root is lambda is equal to 2. Now here we have 1 minus 10, 16. So this can be written as lambda square minus 10 lambda plus 16. Of course 2 8s are 16. So this can be written as lambda square minus 8 lambda minus 2 lambda minus 8 minus 2 minus 10. Okay, we get here minus 10 plus 16. So here taking common lambda, then we get here lambda minus 8. Here taking common minus 2, then we get here lambda minus 8. So taking common lambda minus 8, we get here lambda minus 8 into lambda minus 2. So clearly roots are 2, 8 and 2. So clearly here lambda that is equal to 2 comma 2 comma 8. Now here we can also find these roots by using calciference. Let us see. So press here mode button here. Now if you observe here, we get equation. What is number, friends, here? 5. So press 5. What is our degree here? 3. So degree here, see here, degree is ax cube. So what is number here? 4. So plus 4. Now what is lambda cube coefficient? 1. So press 1 and then is equal to, what is lambda square coefficient? Minus 12. So minus 12, that is equal to, what is lambda coefficient? 36. So enter 36, that is equal to, and what is constant? Minus 32. So minus 32. Okay, is equal to, again press is equal to, then we get x1 that is equal to 8. See, friends, here we get x1 that is equal to 8, and again press is equal to, then we get x2 is equal to 8. X2 that is equal to 8. Again press. If you observe here, we have the values here 1, minus 12, 36. That means what is degree here? Degree is 3. We get how many roots? 3 roots, but it shows only 2 roots, friends. That means x1 is equal to 8 and x2 that is equal to 2, means the second root is repeated 2 times, friends. Repeated 2 times. That is our observation here. Now we can clear here, friends. If I press again, again it shows, friends. Then shift, okay, then press 9 here because it is clear here. So press 9. What is S? All. So press 3. Then is equal to means S is equal to, and then reset to AC. So reset to AC. Okay. In this way, we find the eigenvalues by using calciference. Eigenvalues by using calci. So this lambda is equal to 228. It is called eigenvalues. Eigenvalues. Now I want to find eigenvector. So put subheading eigenvector. So case 1. What is case 1 here? Take lambda is equal to 2, friends, directly. Lambda is equal to 2. So eigenvector form is a minus lambda I into x that is equal to 0. A minus lambda I that is equal to x that is equal to 0. Put lambda is equal to in characteristic matrix, friends. Let us say the characteristic matrix here. See here. 6 minus 2. That means you have 4 minus 2, 2. Okay. We get here 4. 4 minus 2, 2. Okay. And then second row is 2. Minus 2, 1, minus 1. Minus 2, 1, minus 1. Third row is 2 minus 1, 1. 2 minus 1, 1. Now this is order 3. So take x is x, y, z, that is equal to 0, 0, 0. We may also take here x capital X that is equal to x1, x2, x3. Okay, we can take a capital X as x1, x2, x3. That is up to you, friends. Now this is a homogeneous equation. Okay, we have to reduce this matrix into echelon form by applying elementary row operations. So first I make these two elements 0, friends, by using R1. So here I want to make this element 0. We have minus 2. So here we have 4 here. So 2 R2. Already it has negative sign here. So plus R1, that implies R2. Now here 2 2's are 4. So 2 R3. Both signs are positive. So write minus R1 in place of R3. So that we get here 4 minus 2, 2. Clearly these two elements are 0. Now 2 minus 2, 0. Minus 2 plus 2, 0. Minus 2 plus 2, 0. Okay. 2 minus 2, 0. So x, y, z, that is equal to 0, 0, 0. Clearly here, friends, rank of A, we get echelon form here, friends. Rank of A that is equal to 1. Only number of non-zeros only 1, friends. Which is less than 1, 2, 3. Number of unknowns are 3 here. So number of unknowns. Okay, clearly here the system has infinitely many solutions. The system has infinitely many solutions. Now write here, taking common 2, we get a 2x minus y plus z that is equal to 0. 2x minus y plus z that is equal to 0. Okay, we have only one equation, friends. So let y that is equal to k and z that is equal to L. Simply substitute these two yz values in this equation, we get x value. So 2x that is equal to 2x 2x minus k plus L, that is equal to 0. That implies x that is equal to k minus L by 2. So, x value here k minus L by 2. So, eigenvector x that is equal to k minus L by 2, k minus L by 2. What is y value? K, z value is L. Okay. Here the process is very important, friends. Here the process is very important. We can write, we have two arbitrary constant values. So, this can be written as here, friends, k into, see here, this process is very important, k into, so what is k coefficient here? K coefficient 1 by 2, friends. So, 1 by 2. Now, here also we have k here. So, 1. In third element, there is no k, friends. That means 0. Plus L into L. Come on, tell me this time now. What is L coefficient here? We have minus here, minus 1 by 2. So, minus 1 by 2. There is no k here. There is no k means 0. Here we have L, friends. So, 1. Now, I want to take k that is equal to 2, friends, here. K that is equal. That means here 2 by 2. 2 by 2 means we get here 1 into 2. Okay, that means we get eigenvector. First one is 1, 2, 0. 1, 2, 0. See here, and then x2. Here also we have here 2, friends. Multiply, take L is equal to 2 this time now. So, minus 2 by 2. We get here minus 1. Multiply 2 into 0, 0. 2 into 1, 2. 2 into 1, 2. Now, see here, friends. This is very important. Here we have repeated roots 2, 2. For these two eigenvalues, repeated eigenvalues, we get two different eigenvectors, friends. Two different eigenvectors. This is our observation here. This is our observation. For once again, for two repeated eigenvalues, okay, here we get two different eigenvectors. This is our observation. In the next problem, we discuss for repeated roots, we get only one eigenvector, friends. You will see in the next video. Okay, right. Now take case 2. Okay, lambda is equal, friends. Here lambda is, I think, 8. Lambda is equal to 8. Okay, I want to write here eigenvector a minus lambda that is equal to 0. Simply substitute 8 here. We get minus 2, 2. Okay. Here lambda is equal to 8. Write the eigenvector here, a minus lambda into x, that is equal to 0. We get here minus 2, 2. Okay. Clearly here x, a capital X is we are taking here x, y, z, that is equal to O means here 0, 0, 0. Okay. Second row. Lambda is going to get here minus 2, minus 5, minus 1. Minus 2, minus 5. Minus 2, minus 5, minus 1. And last row, two minus 1, minus 5. 2 minus 1, minus 5. Two minus 1, minus 5. Okay. Here also this is a homogeneous equation. Apply elementary row operations to get echelon form. So, first we are making here these two elements 0, friends. Clearly minus 2, here see here minus 2. So, row operation is here, friends. Clearly R2 minus R1 in place of R2. 2 minus 2, friends. So, clearly R3 plus R1 in place of R3. So, that implies we get here minus 2, 2. clearly these two elements are 0. R2 minus R1, minus 5 plus 2, it is minus 3, minus 1 minus 2 minus 3, R3 plus R1, minus 1 minus 2 minus 3, minus 5 plus 2, we get a minus 3. X, Y, Z, that is equal to 0, 0, 0. Okay, actually we are making these elements 0, okay, but second and third rows are same, friends. So clearly the row operation is R3 minus R2 in place of R3. So we get here minus 2 minus 2 2, 0 minus 3 minus 3, clearly last elements are 0, 0, 0. We get here X, Y, Z, that is equal to 0, 0, 0, 0, 0, 0. Now clearly here rank of A, that is equal to 2, which is less than 3, okay. Number of unknowns here, number of unknowns, 3 is number of unknowns, X, Y, Z here. So the system has infinitely many solutions, So you write here taking count minus 2, then we get here X plus Y minus Z, that is equal to 0, X plus Y minus Z, that is equal to 0. And second one is I think minus 3, taking count minus 3, then we get a Y plus Z, that is equal to 0, Y plus Z, that is equal to 0. We have two equations, we need three equations, so that we are taking here let Z is equal to K, friends, Z is equal to K. So substitute here, we get Y is equal to minus K. You substitute these YZ values in first equation here, then you get X plus Y value is minus K minus Z value is K, that is equal to 0. Simply X is equal, we get here minus K minus 2K, taking right hand side we get here 2K. So here eigenvectors say x3, that is equal to, taking common K here, we get 2 minus 1 1, take K is equal to 1, we get 2 minus 1 1. So eigenvectors, you write at one place, friends, eigenvectors, third one is 2 minus 1 1, rest of the first one, second one are 1 2 0 minus 1 0 2, 1 2 0 1 2 0 minus 1 0 2. You highlight these eigenvectors, friends. Okay, this is about eigenvalues and eigenvectors. Once again, right, he given a matrix here, says find eigenvalues and eigenvectors. What is step 1, friends? What is step 1? Characteristic matrix A minus lambda I. I substitute here, then we get a characteristic matrix like this. And then second step is characteristic equation, that is determinant of A minus lambda I, that is equal to 0. Apply determinant, expand the determinant, at the descending order, we get here equation lambda cube minus 12 lambda square plus 36 lambda minus 32, that is equal to 0. You solve this equation, we get the roots 2 to 8. These roots are called eigenvalues. Now we also done by using calcifference. Okay, that is up to you. You can solve directly like this or by using calcifference, that is up to you. And then eigenvector, take lambda is equal to 2. This is a homogeneous equation. Apply row operations to get echelon form here. So I apply our row operations, we get echelon form here. Then I find xyz values here. Here for the repeated roots, we get two different eigenvectors. This is observation in the problem. Okay, how we separate here? Like he given rank of A is equal to 1, which is less than 3. Okay, we get xyz values like this. and then k minus L by 2 k L. You simply write k, that is equal k into 1 by 2 1 0 plus L into minus 1 by 2 0 1 by using this. Take k is equal to, then we get this eigenvector, and L is equal to 2, we get this eigenvector, friends. And then I am taking here lambda is equal to 8. Same, this is a homogeneous equation, apply row operations, okay, to get echelon form. Get echelon form here, and then I solve this equation, we get x, y, z values here, and then right here matrix form. And these three are called, these column matrices are called eigenvectors. This is about the concept of eigenvalues and eigenvectors, friends. Okay, hope you understand. If you have any doubt, please comment in the comment box. Thank you for watching this video. Jai Hind.